I see this is about interpreting the results of an ARD regression model in Sklearn. We're looking at how to understand the meaning of high values in the alpha_ attribute. This attribute shows how precise the model believes each feature's weight is. Specifically, a high alpha_ value implies a low variance for that weight, meaning it's close to zero. Let's explore this further. It's like a detective story, figuring out which features are really important. I'll focus on what high alpha values mean in the context of the model. Remember, ARD stands for Automatic Relevance Determination. High alpha values indicate that the model believes those features are not important. It is doing this by giving those feature weights values near zero because of regularization. Because alpha represents precision, inverse of variance, a high alpha implies a low variance in the feature's weight. Imagine it like this. A low variance means the weight is tightly clustered around a particular value. If the value is near zero, then the feature is not impactful to the model. This is directly connected to regularization in the model. Great job. We are seeing that regularization, a technique used to prevent overfitting by limiting model complexity, is working as intended. The high alpha values tell us that the model has effectively shrunk the weights of these less important features towards zero. It's a signal that the model is successfully identifying and downplaying the influence of irrelevant features. This is a great success of regularization. This option states that the regularization process in ARD regression effectively pushes weights of less important features toward zero. High alpha values are the direct result of this process. They show us that regularization is working to make less important features have less impact on the model's predictions. This is another very important point to highlight. This statement is incorrect. High alpha values actually represent low variance. It's a common misconception, so I am glad we are clarifying this here. Remember, alpha is precision, the inverse of variance. So, high precision equals low variance. This is also incorrect. Overfitting usually happens when your model is too complex and pays too much attention to the training data, leading to poor performance on new, unseen data. In ARD, high alpha values mean the model is doing the opposite. It's effectively simplifying itself by reducing the influence of less important features, preventing overfitting. This is correct. A high alpha value for a feature means its corresponding weight is close to zero. This indicates that the feature isn't much help in making predictions. It's like saying, this piece of information isn't useful for solving the puzzle. Let's break down this question about interpreting high alpha values in ARD regression. ARD stands for Automatic Relevance Determination. It's a technique used in Bayesian linear regression to figure out which features are important for making predictions. Each feature gets its own alpha value, which tells us how precise, or how much we trust, the prediction from that feature is. High alpha means we're really confident about the feature's contribution. A simple example. Imagine we're trying to predict house prices. Some features, like location or house size, are more reliable than others, like the color of the walls. This question focuses on understanding what it means when alpha values for some features are very high, like 1e10, which is 10 billion. I think this is wrong. Overfitting happens when your model learns the training data too well, including the noise, and doesn't generalize well to new data. High alpha values do the opposite. They mean we're shrinking the importance of certain features, preventing them from overfitting the data to noise. That's like saying, hey, these features are pretty noisy. Let's not rely on them too much. It's a good thing. This is correct. ARD uses regularization to control the complexity of the model. High alpha values show that the regularization is working well to reduce the influence of certain features, effectively pushing their importance towards zero. Think of it as saying, we're shrinking those noisy features' weights down to almost nothing. That way we don't put too much faith in them. This statement indicates that options B and C from the original question are incorrect interpretations of high alpha values in the context of ARD regression. It emphasizes the key point that high alpha values are associated with low variance and feature irrelevance. This is opposite to options B and C. I see that you're analyzing feature relevance using ARD regression from Sklearn. This is a great technique for identifying which features are truly important for your model and which ones are adding noise. We'll dive into the details of how it works in the next lines. Okay, so you fit an ARD regression model, and some of the estimated precisions, the alpha underscore values, are extremely large. Think of alpha as representing how certain we are about a feature's weight. A high alpha means we're very certain the weight is close to zero. That's what we are investigating. We'll analyze why this happens. If a feature's weight is essentially zero, that strongly suggests it's not contributing much to the model's predictions, hence it's irrelevant. This is the core idea behind automatic relevance determination, ARD. The high alpha value is a clear signal. Actually, this is incorrect. A high alpha means a * low variance in the weight of the corresponding feature. Remember, alpha is a precision, which is the inverse of variance. So high precision means low variance, and this means the weight is tightly concentrated around zero. Let's clear this up. Overfitting happens when a model learns the training data too well, including the noise and not generalizing well to new data. Here high alpha values are a sign that the model is actually preventing overfitting. It's actively shrinking the weights of less important features towards zero, which is a good thing. Yes, this is precisely what's happening. ARD uses regularization, a technique to discourage overly complex models, and high alpha values are a direct result of that regularization. The model is effectively saying, these features are not needed, I'm shrinking their influence. This is the power of ARD for automated feature selection. I'm analyzing the results of an ARDregression model, a type of regression that uses a Bayesian approach and automatically determines the relevance of features. It's like having a smart assistant that figures out which ingredients are truly important in a recipe. In ARDregression, alpha represents the precision of each feature's weight, how certain we are about that weight. A high alpha indicates we're very certain, meaning a low variance for the weight itself. Think of it like this. A high alpha means we're confident the weight is close to zero. When a feature's weight is near zero, it means that feature has little to no influence on the model's predictions. It's like saying that ingredient doesn't really affect the final dish. Because a weight close to zero suggests the feature is unimportant to our prediction, a high alpha value means we can likely ignore that feature. That's feature selection at work. It's like our smart assistant helped us declutter our recipe. After fitting the ARDregression model and examining the alpha values, precisions for each feature, I noticed some are extremely large, meaning those features likely have very small weights. I confirm. High alpha values strongly suggest the corresponding features are not important in the model's predictions. They have little influence on the outcome. I've learned that high alpha values actually prevent overfitting. It's the opposite of overfitting. Overfitting would show up with low alpha values. This is incorrect. A high alpha value indicates low variance of the feature's weight, not high variance. I agree. High alpha values result from the model's regularization pushing the less relevant feature weights closer to zero. It's like the model automatically performed feature selection. I interpret ARDregression's alpha values as representing the precision, inverse of variance, of each feature's weight in a linear regression model. A higher alpha indicates we're more certain the weight is close to zero. Think of it like this. A high alpha means the model strongly believes a particular feature is unimportant. Let's focus on what high alpha values mean. They tell me the model's effectively shrinking the weight of a particular feature towards zero. That's because a high alpha implies low variance, making the weight's value close to zero. This is great for feature selection. The model is identifying and downplaying the importance of less relevant features. When you see low variance in the weights, caused by high alpha, you know the model has high confidence about those weights values being very close to zero. This strongly suggests those corresponding features aren't making a big difference in predictions. We are certain about their low influence. Weights near zero directly indicate that the corresponding features are barely influencing the model's predictions. This means these features are likely irrelevant. The model has effectively ignored them due to the regularization imposed by the high alpha values. ARD, automatic relevance determination, cleverly achieves this feature selection. This is the central question. The quiz tests my understanding of how to interpret alpha values from Sklearn's ARDregression. I need to associate high alpha values with certain features, then correctly explain the meaning. This is true. High alpha values result from the regularization in ARD. The regularization pushes weights of less important features towards zero. We successfully removed unnecessary features. This is false. High alpha values show regularization is working. The model is not overfitting. Overfitting is related to low alpha values, which leads to high variance in weights. This statement is incorrect. I should remember that high alpha indicates low variance in weights. Therefore, high alpha values are associated with low variance, not high variance, in the weights of the corresponding features. Precisely, high alpha values signify that the associated weights are nearly zero. This means the model considers those features irrelevant to the predictions it makes. This is a key concept in ARD. I see that you're trying to understand what the alpha values mean in Scikit-learn's ARDRegression, automatic relevance determination regression. It's a Bayesian approach that helps you figure out which features are important for your model. Each alpha value represents how precise, certain, the model is about the weight given to a particular feature. I'm focusing on interpreting the results after you've used ARDRegression to analyze data. We're specifically looking at the alpha values, which tell us something about the relevance of each feature used in predicting the outcome. Let's talk about what large alpha values mean. Remember, alpha is the precision, essentially how certain we are about each feature's importance. A high alpha indicates high precision, meaning the model is very confident that the feature's impact is close to zero. It suggests that the feature is not very relevant. That's a great finding for model simplification. This statement is incorrect. You see, overfitting happens when your model learns the training data too well, losing the ability to generalize to new data. That happens when your model gives large weights to irrelevant features. High alpha values, on the other hand, lead the model to assign near zero weights to features, preventing overfitting. Think of it like this. A high alpha value is like saying, I'm pretty sure this feature doesn't matter much. This is wrong. Alpha represents precision, the inverse of variance. A high alpha means low variance. If the model is very confident the weight is near zero, the variance of that weight will be low. The uncertainty about that feature's influence is small. Remember, high precision means low variance. This is absolutely correct. The high alpha values are a direct result of the regularization applied by ARDRegression. Regularization penalizes large weights, pushing the weights of less relevant features towards zero. High alpha values reflect this regularization effect by indicating a high degree of confidence in weights being close to zero. This is accurate. When alpha is very high, the model is effectively saying, this feature is barely impacting the results, or not at all. It's a sign that the feature doesn't strongly influence the model's predictions. The model has done feature selection for you. I see high alpha values mentioned. In the context of ARDRegression, automatic relevance determination regression, a high alpha value means that the model is assigning a very high precision to a particular feature's weight. Remember, precision is the inverse of variance. A high precision implies low variance, suggesting the model believes that feature's weight is very close to zero. This effectively shrinks the feature's influence on the model's predictions. I'm looking at question. After fitting an ARDRegression model. The core question explores the interpretation of high alpha values from Scikit-learn's ARDRegression. It tests your understanding of how these values relate to feature relevance, model complexity, and regularization. Let's tackle ARDRegression model output analysis. We're dealing with Bayesian linear regression here. ARDRegression is a type of Bayesian linear regression that automatically determines which features are relevant. It does that by assigning a precision, alpha, to each feature's weight. A high alpha suggests the model believes the corresponding feature is not important. The correct answers are A and D. This reinforces what we just discussed. High alpha values imply irrelevant features, A, and regularization successfully shrinks the weights to nearly zero, D. The incorrect option, C, high alpha values imply high variance, is addressed in the provided text. I'll reiterate. A high alpha means low variance, not high variance, for the corresponding feature weight. High alpha leads to weights close to zero. Option B, model is likely overfitting, is also incorrect because high alpha values indicate regularization is working well. Overfitting would show up with very low alpha values and large weights, not the other way around.